What is up, YouTube? It's your boy Joe here with another fresh new JavaScript with Joe. We are on day 12. I've been doing this for 12 weeks. Every Wednesday, 4 p.m., we're doing a JavaScript challenge. Come along. To those of you not familiar, we're doing the Advent of Code challenges. So here is today's challenge sent in the chat now. And, okay. And here is where I'll be writing today's code. So it'll all be in JavaScript. You don't have to write it in JavaScript if you don't want to. This website, replit.com, is a really good website for just getting started with any programming language without having to try and install anything, manage any versions, do anything complicated. Just get in and get started coding. And then Advent of Code is a sort of annual event. They do 25 programming challenges in sort of a tech interview style, and every single day you get a challenge. It has 2 parts, and each part of it you get a star for solving. So today we're on day 12, as I said, and let's get started. So day 12, passage pathing. Your submarine, subterranean, subsystem, subsisting, suboptimum. Wow. The only way you're getting out of this cave anytime soon is by finding a path yourself, not just a path. The only way to know if you found the best path is to find all of them. Fortunately, the sensors are still mostly working, and so you build a rough map of the remaining caves. Wow, this looks very much like tree traversal, as they almost always are. So the remaining caves will be my puzzle input. So, interesting. Doesn't look too complicated, that puzzle input, but let's see. So everyone will have a unique puzzle input. So if you make your own account on Advent of Code, my code should solve your problem, but my answer won't be your answer. So this is a list of how all the caves are connected. You start in the cave named Start, and your destination is the cave named End. An entry like BD means that cave B is connected to cave D. That is, you can move between them. So the above cave system looks roughly like this. Cabda. Your goal is to find the number of distinct paths that start at start, end at end, and don't visit small caves more than once. There are 2 types of cave, big cave and small cave. Great. Big cave's written with an uppercase and small cave written with a lowercase. It'd be a waste of time to visit any small cave more than once, but big caves are large enough that it might be worth visiting them multiple times. So all path you find should visit small caves at most once, and can visit big caves as many times as they like. Given these rules, there are 10 possible paths through this example cave system. So start, going to A, going to B, going to A, going to C, going to A, going to end. Start, going to A, B, A, end. Start, A, B, end. Start, A, C, A, B, A, end. Yeah, okay. I'm not excited for this one. Each line in the above list corresponds to a single path. The caves visited by that path are listed in the order they are visited and separated by commas. Note that in this cave system, cave D is never visited by any path. To do so, cave B would need to be visited twice, once on the way to cave D and a second time when returning from cave D. And since cave B is small, this is not allowed. Here's a larger example. There are 19 paths through. I'm not going to go through all these though. Jeez. How many paths through this cave system are there that visit small caves at most once? Right. So this is basically just a graph traversal problem where the big caves are, what are they? It's not that they're, I guess it is that they're cycles. So I guess we could draw the same cave as sort of like this, right? We have to start from the start. We can go to A or B from the start, or B. Then from B we can go to D, but we never will. From B we can go straight to end. From A we can go straight to end. I'm just drawing the same thing, aren't I? I guess what I'm looking for is a way to actually represent this as something I could crawl through, because we're allowed to go back to A, but we're not allowed to go back to C. We're not allowed to go back to B. And then I have to get all possible. Yeah, okay, so they're kind of like, I'm trying to think what I could do here. I could put like weights on each edge, except for the ones into the big cave, and then I could sort of exhaust them as I crawl through them, but it doesn't seem like the right way to do it. Maybe I'll just try and, maybe let's not, just trying to think of a way to make this like a bit simpler to start with, and I'm just thinking, what if we start with this input and just try and read it into a, I don't know how to describe it, like a tree structure or a list of possible, I guess I could do the whole, I could do like a list like this and have S, A, B, C, D, E, and do it that way. So S can't go to S, but S can go to A, can go to B, can't go to the rest. A can go to C and B, and then we could use something other than a 1 to denote this. Oh no, sorry, no, it should be 1. It's that B can go to A as many times as it wants. It can go to D once, but it never should. Is this the way to do this? Can't visit B, these small caves twice, yeah. So what am I doing here? I'm trying kinda, I guess if I was gonna search these, I would do, I'd like crawl down this first. I guess that would be my shortest route. Then this is like a cycle, I don't know, it's not a cycle. Is it a cycle? And then I want to never go to D. So how do I determine that I can never go there? I guess it could just, I guess by crossing these paths, I know I can't back traverse them, if that makes sense, but I guess I'm thinking, why can I traverse this at all? Like, what is it about this? Is it just that there's only one edge that connects them? So you can only traverse it once. So maybe I'm looking for like, maybe this is the grid I want to start with. So why don't we see if we can build that from this? Sort of like a list of nodes. So let's see what we've got there, node. Input. Okay, so we've got our lists. Let's split them into, I guess it's kind of our edges, right? Let edges equal input dot map. string to string.split. So we're going to split on the hyphen. So those are all our edges. And I guess I'm going to ignore big caves for now. So how does that, because that's a good way to make this simpler. So how does this get simpler without big caves? Then it just becomes, well, I guess it's the same by this description, right? Because a big cave is I guess it's bidirectional, right? Once it's got a big cave, but it's not. It's not because we can't visit it again. There's some representation of this as a graph that would be really useful, I'm sure. Okay, well, we've got our edges. Let's make a list of nodes from this as well. So, can I add them to a set? Maybe I'll iterate over each one. Nodes, edges.for each edge, console.log, edge 0, console.log, edge 1, and maybe I'll make a JavaScript set, and I can just use this to add all these items to my set. So let's do node set equals new set. Then I want to add everything I can. So by the end of that, I should have an edges set. Oh, node set, sorry. So there we go, there's all my sets. I think I can convert it to an array. How do I do that in JavaScript? List, or is that something else? Is that Python? Convert set to list, array even. Oh, can use the spread operator. Okay. So let's do const nodes equals dot 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 node set. So now I should have a nodes list as well. Does that help me? I'm not sure. But now I've got nodes and edges at least. So this is everything I need to describe my graph, at least assuming there's no. Alright, so what does this edge, these edges actually are describing something quite different to this, I think. So these are describing, if I actually draw this, I've got start, A, B, I've got A to C, I've got A to B. Let's assume they're different nodes for now as well. I've got B to D, I've got A to end, and I've got B to end. So it's only the big cave that makes this a bit more difficult, really. So if that was all I had, all my roots could be described as this, right? S, A, E, and S, A, B, E, and then I'd be done. So that would be everything. SAE, SABE. But what we actually have, is it worth trying to solve that? Are those even valid? SAE would be one, and SABE would be another one. So that does actually start to give us a root anyway. So maybe let's do that. Let's see if we can just describe this as a tree traversal. How do I do this? I guess I can map this down to like an object. So can I do tree equals, can I just spread those keys? I'd hope not, but I guess. So my first issue is that these are connected. So SBE would also be correct, but let's not do that yet. How am I going to do this? Because I have two B's and two E's. So I think I better just connect these now and connect these now. So that way at least everything's unique. I don't know if I can write this. Oh. It's kind of the opposite of what I want. Keys from array. Oh. No, I want the other way. I want the opposite of that. It's a bit weird, but okay. It's annoying because that's like, I just want the opposite of what that did for me. So I'm just going to refresh this because it's being a bit slow. Loads. Okay, so now I've got my key names but with zeros. I don't really want zeros, I probably want another list. And I can start putting items in those lists. So I can start trying to represent these edges. Oh, these edges in that. So, add edges to tree. Edges dot for each edge. Tree dot edge 0 equals edge 1. So that will overwrite it every time. And does it need to be like this maybe? Yeah, okay. So there we go. So now we've got the last item for each node in the edges array, I believe. So start was set to A, then it was overwritten with B. A was set to C, then B, then overwritten with end, and B was set with D, and then end. C can't go anywhere because we haven't started coding for this uppercase A being a big cave. So instead of that, I just want to append, right? Equals tree edge 0 dot append edge 1. I don't need the equals. Oh, not a function because it's the tree edge 0 b start should get the value. It is always a list, so why can't I append? Append is not a function. Oh, that must be from Python, apologies. Cool. So that is basically this. Now what do I do? I guess I want to sort of span out, so I want to go across all possible paths. So I need to write something that starts traversing this tree. So it needs a start node, path so far. Is that it? Equals. So the base case would be a tree of length 1. And what am I looking for here? Just trying to get return all paths, or return only paths that end in end? Probably, well, let's get all paths anyway. So our simplest tree will be the start node is the end node. No, it wouldn't. It would be I guess it's like if we have either our tree could just be this, right? A, or it could be start and then end. Should probably go with start and end. So the base case would be, so let's do base tree equals, it will be start, end, end. Oh, and an empty array. And that should return maybe just a list of all possible routes through it. In this case, it'll just be one start, comma, end. So I guess we have to go into, so get all potential next nodes, and then do I call base tree again? That can't be right. And I've been calling it on like base tree end part so far, and then I'm returning, I don't know, parts? No, part so far probably. So next is equal to, oh, I need the tree. So this will be base tree for now. So traverse base tree start part so far will be nothing. Why are you complaining? Oh, because of this. So next will be equal to tree start. It's not start, maybe it's current. Current, and then we'll do base tree end, which won't be end, it'll be, usually there's for each, right? So next dot for each node, I guess we could call it nexts, and this could be next, for each next. Then in here we're going to do base tree next part so far, and then so at the moment it's going in here, next is equal to just end. So for end it's going to call end. Why have I written end there? It's not end, it's just the tree. Tree end part so far should say start, but it doesn't. So we need to say path so far equals plus equals current. Yeah. Then path so far is now start. It should call this with end. Enter this again. Path so far equals start end. Next is nothing. So is it that if next is empty, then I return? Is that right? If next equals empty, then return, otherwise iterate lower. Is that right? Else iterate lower. Will that actually terminate? Not sure. Let's see. Base tree is not a function. Traverse tree. So it finished. So that's pretty good. So let's call this parts. It will just return one string, I suppose. Oh. So let's say no edges left, and console.log traversing tree. Let's see where it gets to. So it hits traversing tree once. Okay, so let's track this through. Path so far is start, next is end, if next is empty, which it isn't. In fact, we never reach empty. So how is this function ending? Does it need a big returns? I need to do like part so far equals this. No. I probably need to do something here to actually catch it as it comes back up. Or should I just do it only when it's empty? No, because this is going to turn into, this will only return one path. Even that would be good though. But it never even goes into here. So console.log next. Should just say end once. Traversing tree end. And I'm calling it again with the same tree. Though, right, there's no for each then. So my question is, why isn't this log running? I'm guessing maybe this isn't equal to this. Then there's nothing to iterate over. And then it just ends, that's why. So how do I check if an array is empty? I guess I just have to do .length equals 0 instead. .length equals 0. Okay, now we've lost the path somehow. Which is strange because the path so far is definitely defined there. So is this path so far actually filling up? Ooh. So path so far is empty, and the second one, path so far, is, let's put it after there. So we should see start and then start end. So that is what I think it is. So why is this return not returning? No edges left. Is it just because it's a const? Seems like it would error there. Right. So I feel like I'm still not doing anything with that, but it seems to be working. Path so far is being passed in. It's spelled the same. Maybe I'll just try logging that as well. So it doesn't seem to be returning anything, even though it is returning it here. Let's just try logging it here as well. So after no edges, what do we have? Definitely start end. What the heck? Ah, okay. So when we finish the second run, it's this one that's finishing, and in the first run this one never finishes. So is it just I need to return it here as well? Did that work, or have I just logged out start end everywhere? No. I think that might be it though. So when the path terminates, it should be returning this, but it's returning that here, and we're doing nothing with it. So we should be returning it when it terminates, but is that when it terminates? Let's get rid of some of these. Yeah. So I'm missing a return somewhere basically. Do I need to do it outside of here, do I? I'm just guessing now. Well, at least it says start. So it's, okay, so now in the first run it's getting here and it's returning, which it shouldn't be doing, but it is printing something out. So that suggests these aren't running. So on the first run start, we're going into here, then we're going into here with end selected. So it should be coming here, returning path so far. So this bit should be start end. And I'm returning it, but I will have multiple returns for each. Would that be a problem? Probably, because I'm going to return a few things. It's definitely not that. So where is it? Should it be outside of that? Return path so far. Doesn't really make sense either. So that's inside the else now, but it's still giving us start. This is the return I should want, but do I just need to overwrite path so far with this? Okay, right, I think that's it then. I mean, that's the base case. That should be the easiest one. So now we can start playing with this. So what happens if I put something in the middle? With a comma. Start bend. Okay, so let's start doing something like, let's add a comma in here. Oh, it's a bit annoying. Okay, let's just do let's do it afterwards. I mean, there'll be a trailing comma now, but I don't think that's that bad. Right, start be end. Okay. So what happens now when there's two options? So we should be able to actually try it with our real tree. but it's going to have multiple. So, what happened there? So what we've not dealt with at all is that there's more than one answer. So this would work if there was only one answer. What it's actually going to do is return every terminating path all at once. What's that? So now it's doing start, AC. Alright, so it goes start and it gives me A, and then it gives me AC, gives me AB, then B gives me D and end. Then we go back up to the A where it gives me end. And then I get another BD. What was my list? Start A. Let's see, what does my tree look like? That's probably why. Start A. So A goes to A, we get C, B. Okay, so we get C, C has nothing. We get B, B has D and end. Then we're back up here, we check end. Then we go into B from here. And B has... what? D end is from the B, then we go into A's end, then we go into B, which gives us D and end, right? So that's what it's doing. So it's just traversing our entire tree, which makes sense. What we should instead be doing is sort of keeping these paths separate somehow. So how do I do that? Instead of having one path, I need a simpler tree than this, I guess. So let's say that start goes to A, B, B goes to end, and A goes to end. What does that give us? That just gives us one line as well, I suppose. Oh, I need to use base tree. Oops. So, base tree. So we've got start, goes into A, checks the key for A, which gets end, and then goes into B, end. So how am I going to do this? How do I keep track of, like, how do I separate this? So I'll be in S. Both go to A, but I wouldn't know, I don't know if I get to E until I get to the end, right? Like here I have an end, and it's at that point that I know that this is a path. It's only when I get to SABE that I get to the end and I know this is a complete path. So should I just I should probably return all separate paths, and that way even if there's a C here and that's not a correct path, I should probably still be keeping it. So do I need to like do I need to do like a path so far, and instead I'm returning the path so far, and then in here I'm doing like paths so maybe parts? Could I do like a parts object, sorry, parts list, and do parts dot push this? Oh, 2, 3. So just delete one. of some JavaScript. How did I write? Empty paths, and then let's do paths.push. Can I access paths? It's not defined again. Oh, I already have a paths variable. Path so far. Oh. So we seem to have some duplicates. Oh no, because I call it twice. So I don't need them both. Do I even need, I'm not even storing a variable now, right? So just do this. Path so far. So that is all of the paths we built up. So we've got start A, start B. So this should work with our original tree, but now we have all possible paths, which isn't great. But within there, SAE, right? We've got, is this? Yeah, SAE there, and we should have SABE. SABE. We also have SBE, which I didn't have. Is that a real one? Oh, B does go to end. Did I draw that wrong here? Oh no, it's here. Right, I see. Right, yes, because that can go straight there. So now I could just get all the roots that end in end, and then I've got all my roots. Well, I've got all my direct roots, not using these uppercase edges. What am I going to do when this is? It could be okay. So now I need to deal with this uppercase A, which I should be able to do just by, so hopefully I don't need this base tree anymore. Let's see the tree I built. So for A to be revisitable, anything that A is linked with is also linked with A, which should for this case mean that tree dot B dot push should have A in it, and then tree C should have A in it, and actually N should probably have it as well, but I'm not going to do that. Will this even run? No. Because it runs forever. Why does it run forever? Because I need to get rid of these edges as I traverse them. Oh, that's not real. Right. So what we will get then is what we're actually saying is sort of infinite cycles. So I'm saying that B can go to A as many times as it wants, but also A can go to B as many times as it wants. But what I actually just want to say is B can go to A as many times as it wants, but A can only go to B once. So I could add weights to each of these. So instead of just pushing them in as an edge, I could do that. needs to be tree edge 1. Tree edge 1. Like that. Again, what's it complaining about? Okay, go way back. So instead of just pushing edge 1 in for each of them, I need to push it doesn't need to be an array. Tree edge 0 dot. No, let's just see if we can pop them out as we find them. So do tree dot pop. Next, I guess. No, pop current. It's just going to completely destroy the tree though. Tree pop is not a function. Because tree is an object, so I need to do tree next dot pop current. Ooh. So there still seems to be some stuff in the tree. But was there always that much stuff in the tree? I don't think so. Just A, B, and C, B. Yeah, so it seems to have got rid of what D's and N's, right? Which kind of makes sense. What does that actually mean? So start can go to A and B. So far. So there's no end in there anymore. So why is that happening? Is it just one tree is surviving? Do I need to pop them after I traverse to them? I'm just guessing now. I don't know if that's any better. Looks about the same. Got some ends. Why are there still... So it's only doing it when something is visited, I suppose. I don't know. It only seems to be getting rid of B's and N's, though the answer, everything I'm looking for is still there. SAE, SABE, but SBE isn't there anymore. So I'm guessing I'm sort of infecting my other passes. And if I do this, will it still error anyway? Because that's my problem. Yes. Okay. So that's not worked either. So I think what I would do next is instead of just pushing the edge in, if I was pushing something like this, I don't know why that's erroring. Because it's looking for, I mean, it's not that I want to push at all, I suppose it's that it should be an object instead, like that. And then I should be saying, I don't know. I think I'm going to end it there, but that's what I would try and store an object like this in there. And then I could check before traversing if I'm allowed to traverse this edge. If I am, decrease that number. If I'm not, and then for A, I can make that number, it doesn't really matter, I mean, as long as it was like 2 or 3 at the moment, but I can make it a really high number, or I can use something to denote infinity that we check. That's probably what I'll do next, but there's only 5 minutes left, so I'm going to leave it there. Again, not very far in. These tree style questions are quite tricky. I mean, look, I've only written about 40 lines of code, but that was not easy to write, especially without going and learning what that is. But yeah, I think I'll leave it there. So thank you very much for watching, everybody, and I'll see you next week.